Okay, exponents, lesson 1. Powers, whole number exponents. Yeah, we're going to get fraction exponents too. Oh, how fun is that? All right. Repeated multiplication, 2 times 2 times 2. What's that, guys? 8, not 6, not like 4 or something. Okay, that's a repeated multiplication. We can write that in exponential form. This is not new. You saw this last year. You actually saw it in grade 8 too when you were doing good old Pythagoras, like the last question on our test that only 3 of you got. Okay? Exponents can also be used with variables. This is, kind of looks like a portion of a Rubik's Cube. But if I said to you, this was 2, no, let's call that 1. That's the length 1, okay? So how long is this side? Well, that's also 1. So how long is the length? That's 2. So these are all squares, 1, 1. This length is also 2, right? And guess what the height is? 2. So if I said to you, what's the formula for the volume of a cube? We don't just have 2 dimensions, length times width. We have a third dimension, right? And you should have done this in grade 9 too. So volume is length times width times height. These dimensions are all the same. Length is 2. Is this the length or is this the length? Is there right or wrong here? No. Just turn your cube the other way, and if you like this to be the length, well, now it's your width. Okay? Doesn't matter. It doesn't matter. I can go height times width times length. It doesn't matter what order these in. These are in 2 times 2 times 2. That's the volume. I can also write that as, well, 2 cubed, and we know that's 8 units cubed. But we're not in our measurement chapter. That's the next one we're going to do. We can say this is also a. Volume, length is a, width is a, height is a. How else can I write this? A cubed. Yeah, 3 A's. A times A times A cubed. That's an exponent. That's a power. Okay? Definition, a couple of easy marks on your test. The whole thing is called the power. Okay? It consists of the base, that's this guy, and the exponent. That's, what do you call that in English? If, I don't know, I have a word, it's not a subscript, it's a, Annika? Superscript, yeah. Okay? The superscript, that's the last time I'm going to use that word, is called the exponent, okay? Exponent. Whole thing's called the power. Should be easy pickings. You got a 50-50 chance. Which is the base? Which is the exponent? What's the base? 4. Yeah, just look here. That should be easy, right? The exponent is, I wrote it as an exponent. The exponent is 5, okay? The base here, -3. The exponent, 6. The base is x. Doesn't matter if it's letters, it's the same thing. Exponent is y, okay? That's like grade 2 stuff. If we have a number in front, and if you recall, this was on our first sheet we ever got here, or review sheet, all right? P is the base, 3 is the exponent. Guess what that 7's called? Well, it says it right there, a coefficient. Just like 2x, x is the base. Here, is there an exponent? There is. It's a 1. If there's nothing there, it's a 1. This is the coefficient, okay? State the coefficient. 8, -3, okay? This is the tricky one. Is it 7? Is it like, I don't know, -7? Is it not anything? Or is it something else? Well, can I put a 1 here? Sure, why not, you say? Right? 1 times a to the 8 is still a to the 8. I'm going to make this line a little longer, and I'm just going to rearrange it. Do you see what the coefficient is now? It's 1/7. Yeah. Okay. 1/7 times, I can even write that in the middle. A8 is the same as A8 over 7. Okay? That's the same thing. Again, can I like put a 1 under that if I want to? Sure. How do you multiply fractions? Multiply straight across. 1 times A8 is A8. 7 times 1 is 7. That's the same as this. Okay? Let's get rid of that. I have grade 11 still asking me this. Okay? Because the answers in the book show like this. And they get this when they simplify a big long equation, 10 lines. Okay? Stuff's getting pretty complicated. This is the same as that. All right? Repeated multiplication. That just means we don't want to multiply it all out and make it simplified. We want to break it down, just like our radicals, right? This is what we did last chapter. I could write root 4 times root 3. That's repeated multiplication. The questions last chapter said a product of radicals, right? Okay? So we're breaking it all down into its little pieces. So if this is 7 times p cubed, there's only one 7 here. That exponent 3 applies to the p, so there's 3 p's. Why is that one different? Because we have brackets. Everything in the brackets is applied to that 3, right? So we have 7p times 7p times 7p. And I can rearrange that any way I want, okay? Let's put all the 7s out front. 7 times 7 times 7. Then I'm going to have the p's, p times p times p. Okay, it's the same thing. It's repeated multiplication. But now, what's 7 times 7? 49 times 7. They're saying it's 343. Okay? We'll see this when we get to our big rule sheet. Write each as repeated multiplication. So all you want to do is break it out into all its bits and pieces. A to the 4th power, how many a's is that? 1, 2, 3, 4, and I have 1b, and that's it. Okay, does this 4 apply to this 3? No. And we don't know yet. We need a lot of practice with this, some of us. But no, it does not. Okay, I have a 3, but AB is to the 4th power. So I got AB times AB times AB times AB. And if I want, if this is helpful, collect everything that's the same. How many A's? 4. How many B's? I also have 4. Okay? This 4 applies to both the A and the B. Everything in the brackets. Here, does it apply to the A? It doesn't. A is by itself. If you want to put an exponent there, it's A to the 1. B, 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 B. 4 B's. Okay, next question. Does that 4 apply to the 3? Does it apply to the A? How about the B? That's everything in the brackets to the 4th power. 3AB times 3AB times 3AB times 3AB 4 times. Okay? Again, I can rearrange this. I could put all the 3's first, then all the A's, then all the B's. I'm going to be lazy and not write that one out. Okay? 10 cubed means 10 times 10 times 10, which is, how many zeros do I have? 3 zeros. Okay? 3 to the 4th power. Some of us were working with this already, right? Okay? Because if we want to find the 4th root of something that equals 3, it's 3 times 3, 9. 3 times 3, 9. 9 times 9 is, yeah. Or if you want to go 3 times 3 is 9, times 3 is 27, times 3 it's 81. Okay, here's the tricky one. Remember this on the review sheet? I had one of those and I had one of these. Here we're seeing it again. Okay? Negative 6 squared. Everything in the brackets is squared. So it's negative 6 times negative 6. What's a negative times a negative? Positive. 6 times 6 is 36. That's different than this one. Think BEDMAS. Do the exponent first. That's 6 times 6 is 36. Then we have our subtraction last. Okay? This one's positive, this one's negative. You think that's going to be on your test? I tell you guys, and half of you will still not get it. All right. Patterns. This is important. Believe it or not, this is like a question on the government exam. Okay? They like patterns. They like to do this. Should be an easy mark. Get this one and you only got 59 others to solve. Okay? Government exams about 60 marks. 10 to the 4. Well, 10 times 10 times 10 times 10 is 10,000. 10 cubed. We just did that one. That's 1,000. How did this change from here to here? We have one less zero. 10 squared is 100. Is that one less zero? 10 to the 1 is just 10. Is that one less zero? What do you think this one's going to be? What's one less zero from 10? 10 to the 0 power. Have we said this yet? What's anything to the 0 power? Okay, 3 to the 4 is 81. We just did that. 3 times 3 times 3 is 27. From here to here, I divided by 3. 3 squared is 9. Is 27 divided by 3 9? Yeah. 3 to the 1 is just 3. That's divided by 3 again. Forgot my 3. Okay. 3 to the 0. What's 3 divided by 3? So again, it looks like it makes sense. Okay. We're going to see this again when we get to negative exponents. That's something you didn't do in grade 9. The results above. A general rule: when a base is raised to the exponent of 0, a, I don't care what a is, anything to the 0 power is 1. Okay? So 6 to the 0 is 1. Negative 9 to the 0. Is that like negative 1? This one isn't, because that negative is also in the brackets raised to the 0 power. However, what happens here? Think BEDMAS. Visually, split it up. What's anything to the 0 power? 1, but I have a negative here. Okay, that one is negative 1. 6 squared to the 0 power. What's anything to the 0 power? That's 1. So I have 2 times 1 is 2. Or maybe you want to do this. Well, BEDMAS says do the brackets first. That's 6 squared, that's 36. But it's still to the 0 power. That's 1. 2 times 1, I get the same thing. Okay? But that 2 is not raised to the 0 power, right? Okay. Here is your big handy dandy chart. These are the exponent laws. Okay? You might want to refer back to this page for the next couple of lessons. Okay? Because it's all right here. But you can't have this page on your test. You got to stick it in your noodle. The only way you do that, guys, is practice, 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 right? Okay? So we got to fill in this, so it'll take a minute or two. Let's prove some stuff to ourselves. This is a numerical base. That means this base is a number, right? 8 cubed can be known as 8 times 8 times 8. 8 squared is 8 times 8. How many 8s do we have? 1, 2, 3, 4, 5. Okay? So how do we get from 3 and 2 to 5? We add them. And last year, hopefully, your teacher said, if you multiply with the same base, what do we do with our exponents? We add them. I don't care if it's numbers or letters. If you're multiplying with the same base, what is 3 plus 2? 5. Okay? A cubed times a squared is a to the 5th power. I don't care what m and n are. I don't care what a is. If you multiply with the same base, what do you do with your exponents? You add them. Why is it m and n, you ask? Well, it doesn't matter. They could have used any letters here they wanted. Okay, R and S, P and Q, right? Another A and another B. What this is saying is, I don't care what A is. I don't care what M and N are. You can do this for anything. All right? That's multiplication or product law. Quotient law is very similar. Only you don't add them, you... Let's just look at this. A cubed, that's 8 times 8 times 8. Divided by, that's not how you want to write divided by in Math 10. You want to write it as that line over a squared, 8 times 8. What's 8 divided by 8? 1. Get rid of it. 8 divided by 8 is 1. Get rid of that one. What do I have left? Just an 8. What is 3 minus 2? So when you multiply, you add. When you divide, you subtract. Okay? Doesn't matter if it's 8s or A's or C's or Q's or elephants. Okay? When you divide, you subtract the exponents. A divided by A, it's gone. A divided by A, it's gone. This is just A or A to the 1. Okay? Again, I don't care what M and N are. If you're dividing with the same base, you can subtract the exponents. Okay? And this is just to make a professor happy because, well, if A was 0, you can't divide by 0, right? But it's not going to be. So don't even worry about this, okay? Now you will worry about it because it's got a smiley face. No, cross that out. All right? Okay, that's quotient law. There's a couple more. This is different. Remember a couple of questions ago, we kind of proved to ourselves this exponent applies to everything in the brackets. It applied to the 3 because I got 4 3's. It applied to the A, I got 4 A's. And it applied to the B. I got 4 B's. So let's kind of prove it again. If I have 8 times 7, I know that's 56, but I don't want to write 56. I want to keep them separate. Cubed, that's 8 times 7 once, 8 times 7 twice, 8 times 7 3 times. Let's split them up. That's repeated multiplication. Now let's just sort them. How many 8s do you have? 3. How many 7s? 3. So once again, this 3, it applies to everything in the brackets. If you got 17 numbers and letters in there, that 3 applies to every one of them if they're in the brackets. Okay, same thing if it's letters. This is called the power of a product law. I'm not going to ask you what it is. You just got to know when you see this what to do. So does that M apply to the A? Okay, does it apply to the B? Yes. It applies to everything in the brackets. All right? I don't care if it's multiplying or what's a quotient? The answer to a division question. It's the same law. Just think this. This applies to everything in the brackets. And it doesn't matter if it's multiply or divide. Okay? That applies to the 8. It also applies to the 7. A divided by B, it's all in the brackets cubed. So that 3 applies to both things. Okay? I don't care what n is. It applies to everything in the brackets. That's all you got to say. Okay? I said that 7 times. I didn't write it, but if you think it's helpful, exponent applies, this is bad English, to everything in brackets, okay? I'll say it like another 9 times before we have our test, but, okay, let's write it. All right? One more. Everyone confuses this with the multiplication, the product law. It's a little bit different. Okay? How many bases do I have in this question here, highlighted? Are there 2 bases or 1 base? What's a base again? Yeah, the 8's a base. There's only 1 base. You're not multiplying something with the same base. There's only 1 base. So you don't add these. What do you do with these? Let's find out. Yeah. Okay? We got 8 cubed squared. So remember, if you do that, 3 squared, it's 3 times 3. If it's x squared, it's x times x. Okay? If it's squiggly squared, it's squiggly times squiggly. If it's 8 cubed squared, it's 8 cubed times 8 cubed. But I can also write 8 cubed as 8 times 8 times 8, right? 8 cubed is still 8 times 8 times 8. How many 8s do you have? 6. How do you get to 6 from 3 and 2? We don't add, we multiply, okay? This you have to stick in your noodle. This is called the power of a power, okay? So if you have A, it's the same thing. What's 3 times 2? Okay, I don't care what this is. Squiggly, right? So this, there's only 1 base. It's not, let's go back. It is not A to the M times A to the N. There's a base times a base. If you multiply with the same base, you add the exponents. There's no second base here. It's just A. So you don't add, you multiply. Okay? Everyone likes to confuse those two. It's a power of a power. There's only 1 base. Other than the negative exponent law, guys, that's it. That's your exponent laws. This is what you do to get answers, proper answers. Okay?
What you said is the hardest, you know?
Well, it's one that's normally, most frequently, rewritten by kids. So, don't worry, it'll get, you're looking at it going, oh, that's easy. Well, you know, they're going to get a little more complicated. Okay? It's easy to make mistakes here. Just a couple of examples, guys, and you're on your own. Use exponent laws to simplify and then evaluate. Because, you know, we're not just going to do exponents. We're going to mix in radicals with this later, too. Oh, yeah. Okay? What is this? What law is it? You don't need to know. The more familiar you are with it, the more likely you're going to get the right mark. But I'm never going to ask, what law is that? You just need to know to get the right answer. This is multiplication. That's what that dot means. Now you got to ask yourself, that 4 and that 2, I know I got to do something with that. Do I add them, subtract them, multiply them, divide them? Some of us already know. And the more you did of this in grade 9, the more likely you are to know this. And when we don't, guys, that's why we have this nice handy dandy table. Which one of those looks like this in here? It looks like that. You're multiplying with the same base, 3 and 3. So you add your exponents. 4 and 2 is 6. I'm not going to do this for every one, but I have had kids in the past, when they're getting really confused, they don't know what to do, use a repeated multiplication. You'll get it right every time. But kids don't want to do this because they think, oh, that's just way too much work. What's 3 to the 4? 3 to the 2? How many 3's do you have? Bingo. Okay? If you got to do that to get the mark, guys, do it. Okay? Let's try that here. This is the last one. -2, -2, that I'm going to write out like this. Okay? How many do I have? Is that -2 to the 5th power? Is that 5 negative 2's? Yes. How many do I have on the bottom? There's 3. This is the same as that. What's anything divided by itself? 1. That's 1. That's 1. That's 1. What do we have left? -2 times -2 or -2 squared. Okay? So, you can get the answer like that. But what's the rule? I'm dividing with the same base. Where's that? That's here. I'm dividing with the same base. What do I do with my exponents? I subtract them. What is 5 minus 3? Yes. Okay, that's not an 8. It's not an S. It's supposed to be a 5. All right. C. Am I multiplying with the same base? Or is this something else? This is a power raised to another power. I don't add. 2 times 3 is 6. Okay? I'll do these a little quicker. Okay, because you can watch me do 8,000 of these. You're not going to know how to do it until you do it yourself, right? Just like any sport. Sorry? Oh, yeah, I guess it does. Yeah, thanks. I didn't answer my question. I just simplified. Okay. Ooh, that's ugly. What's 3 times 3 times 3 times 3? Or 3 to the 6th power? I don't know. I'm going to look it up, guys. But we should know this is a calculator exercise, too. 3 to the power of 6 is 729. Okay, -2 squared. This one we can do in our head. -2 times -2, positive 4. 5 to the 6, that's too big. Who cares? All right? These ones, just simplify. Because I can't evaluate this. I don't know what A is. Okay? Multiply with the same base, add the exponents. Multiply with the same base, add the exponents. Is that a 0 here? Or is this something else? It's a 1. If it was a 0, it wouldn't be there, right? It's x to the 1. What's 6 plus 1? 7. Multiply with the same base, add the exponents. 7 and 0 and 4 is 11. Yes, that's the same as anything to the 0 is just 1. I still have b7 times b4, okay, times 1. 7 and 4 is 11, okay? Either way you want to think. Dividing with the same base, 8 minus 4 is 4. 10 minus 2, 8. Dividing with the same base. Power raised to another power. Don't add them, you multiply. Okay. Power raised to another power. 25, not 10. Okay. Does this 9 apply to the x or to the y or both? Both. Everything in the brackets. Everything in the brackets. 4 squared, well, and this one doesn't say evaluate, but if you want to write 16 here, please be my guest. Okay? C squared over 16. Does this 6 apply to the t, the s, or everything in the brackets? Everything in the brackets. This 5 apply to everything in the brackets? Yes. 2 to the 5th power is what? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, does this 4 apply to everything in the brackets? Even the minus sign? What's a negative taken to the power of something positive? What's a negative times itself an even number of times? Positive. If you see that, you don't even have to worry about the sign anymore. I'm going to write this really weird, okay? This is negative 1 times 3 times p times q. We okay with that? Is that the same thing as this? Yeah, what's negative 1 times 3? Negative 3. I've separated all of this stuff out, including the minus sign. This applies to everything in the brackets. And again, negative 1 to the 6th power, 10th power, 48th power, 116 power, it doesn't matter. A negative, an even number of times is always positive, right? This is positive, so forget about it. Because if it's plus, we don't put a plus out front, right? We just ignore it. 3 to the 4th power is 81. 3 times 3 times 3 times 3. P4, Q4. Okay? That's one confusing way to do it. If you want to just think negative 3 to the 4th power, you will get the same thing. But if you plug that in your calculator and don't put brackets around it, you're going to get negative 81, aren't you? Because your calculator will do this part first and that part later, okay? It's nice to think. Again, that's a question on the government exam. You're not allowed to use your calculator, okay? All right, lots of practice, guys. How are we going to be doing tomorrow's stuff if we don't do this completely? We're going to be hurting, right? So when I give you these questions, it doesn't mean do half of them. It means do them all, okay?